All right, so I told you about this factoring flowchart, and I'm going to show you how to use it right now. So I guess the first question would be, all right, well, where do we actually find the factoring flowchart? Well, it's all the way back here. So if you just go to our Blackboard course, I'm going to zoom in here for us. Come over here to YouTube videos, scroll down to Chapter 7 Polynomials, and you're going to see it right here. It's a PDF file, so you can just click on this right here, and it'll download for you, and then you just open it up. I would suggest printing it if you can. If not, just copy it down. Okay? So let's go back and let's look at some examples using this now. So you always want to start on the far left-hand side. So this is where you're going to start. Okay? And with every single problem, you're just going to go from left to right. So the first thing you're always going to try to do, I'll zoom in here for us, is we're going to try to factor out a GCF. All right? So some problems have a GCF, some problems don't. All right? But you always want to start there. Then you're just going to move from left to right. So the next question is, what type of polynomial do you have? And you're going to notice here that we have three types. All right, we have at the very top, we have a binomial, then you have a trinomial, and then you have a polynomial. Okay. I'm sorry, a polynomial with four terms. I need to be a little bit more specific. So for us right now, all right, what we've learned so far in this class, and I'm going to highlight the pathway here, is we've learned polynomials with four types, and then we know, well, if there's four terms, we factor by grouping. And we also looked at the case where if you have a trinomial, you can have a equal to 1 or a not equal to 1. Regardless, it tells you exactly what to do. And it even provides a little like a little example there for you. Okay? Now, the most important one, I think, in this entire flowchart here is going to be polynomial type trinomial with a not equal to 1, because if you look at this, it says use the AC method, create a four-term polynomial, and factor by grouping. And you can see how this like little line right here at the very bottom kind of connects those two together. Okay? So what this flowchart is actually meant to do, it's meant to just keep you in order in terms of how do you approach a problem. Okay? Because I know a lot of us sometimes, we may be sitting back thinking to ourselves, well, I don't even know where to start. Okay, well, you know where to start. You try to factor out a GCF. So what I'm going to do here is I'm going to do a couple problems, not many, because I just want to show you how I use the flowchart. Okay, so I'm going to zoom out here a little bit. Like I said, hopefully you have this printed up and stuff like that, so you can just refer to it. And let's do a couple problems. All right, so I'm going to try to write it off to the right-hand side here. So here's our first problem here. Factor. And we're going to do 3n to the second. Actually, let's make it 3n to the third. 3n to the third minus 12n to the second minus 30. Okay? So first step, you always want to try to factor a GCF. So when I look, I see each term has a multiple of 3 and also has the variable n. So I know I can factor out 3n. So I'm just going to go ahead and factor that out. That's going to leave me with n to the second minus 4n minus 10. So there was my first step, was factoring out a GCF. Now I move over to the right, and I'm going to ask myself, okay, well, what type of polynomial do I have? Well, you factored the GCF out. So that's going to be out front. What I'm really concerned with, what's on the inside. Okay? So that is a trinomial with a equal to 1. So trinomial with a equal to 1. Now, if you're asking yourself, well, what do you mean by a equals 1? Remember, and I'm going to write this at the very top of the page. We studied trinomials of this form right here, where a equals 1 and then a did not equal 1. Okay? So for us, if you look at the inside of the parentheses, the coefficient in front of the n squared, and I'm gonna write it in red, is a 1. So it's this case right here. So according to that, we're gonna find two numbers that multiply to give you factor 1 and factor 2. That's what the F1 and F2 means. and they have to multiply to get C and add to get B. So let's go ahead and let's apply that. So 3n, the multiplication of two binomials. I'm going to write an n and an n. I'm going to write I always copy down my first sign. The second sign has to be a positive because a positive times a negative equals a negative, which is what I wanted. And now underneath, I'm just going to write out the factors of 10. So that's going to be 1 and 10, 2 and 5. And here's what I know. I know that when I combine these terms, okay, they got to give me -4. And I know one of them is negative and one of them is positive. Now, if you look at the first case, 1 and 10, that's never going to happen. And what I mean by that is you can have +1 minus 10, which is -9, or -1 plus 10, which is +9. And you want -4. So I know 1 and 10 does not work. So I'm just going to scratch them out. What about 2 and 5? Maybe that'll work. I don't know. -2 plus 5. Well, that's going to be 3. And then 2 minus 5 equals -3. So that doesn't work. And since both cases do not work, you cannot factor n squared -4 and -10 any further. So although it looked like you could, you can. So our final answer, and I'm just going to erase all this now. Our final answer for this problem is 3n times n squared -4n -10. Okay? And that is what the first problem looks like. All right? So I'm going to go ahead and erase stuff, and I'm going to do another one for us. Okay, here's our next problem. Let's do, oops, sorry. Kind of zoomed out there a little too much. It's really hard because this flowchart takes up so much real estate on the screen. All right, here we go. How about 2x to the second minus 5x minus 3. Remember, you always start here. Factor out a GCF. In this case, there is no GCF. So we move over, polynomial type. Well, we have 3 terms, so that's going to be a trinomial. And if you look, a does not equal 1. In fact, a in this case equals 2. So we're going to use the AC method here. So step 1, let's get an idea of what the final answer should look like. Remember, copy down the first sign. Second sign has to be a positive. Step 2, we're going to take a times c. So it's going to be 2 times 3, which is 6. And then we write out the factors of 6. I can write them a little smaller, I guess. 1 and 6, 2 and 3. And our goal is to pick the pair that combines to give you -5. And that's pretty simple. +1 minus 6 equals -5. So it's going to be that first pair. Okay. Step 3. We're going to rewrite -5x as x minus 6x. Okay. And if you're asking where did I get that from? Well, the coefficients are 1 and -6 from step 2. And now step 4, factor by grouping. So I'm going to rewrite 2x squared plus x minus 6x minus 3. I group my first set, 2x squared. I group my second set, and I need to be careful because that middle sign is a negative. That middle sign is negative, which means this -3 on the very end, when I group it, it changes to a +3. And I can zoom in now. We don't need the flowchart anymore. So mini GCF, factor out an x for the first. Mini GCF for the second, I can factor out a 3. Notice that my binomials inside the parentheses are the exact same, which means I can factor that out. And what's left over is going to be the x and then the -3. So x minus 3. All right, and there's your answer for the second one. So when I scroll out here, this flowchart does not give you the answer. What it provides you is a systematic way of approaching a problem, which I think is really important for us to do. We got to be able to approach problems in such a way that everything just kind of flows, hence the name flowchart, okay? So let's do one more here, okay? We'll do one more, and then we'll see what happens, okay? So let me erase real quick. All right, so here's our last problem. 2x to the third plus 12x squared plus 18x. So once again, we start with factoring out a GCF. So when I look at this, I can see a 2 and an x. So I'm going to factor out 2x. So that's going to give me x squared plus 6x plus 9. Okay? Now from here, polynomial type. Well, I have a trinomial. All right? In this case, a equals 1, because it's right here. It's inside the parentheses. So I can just go ahead straight into my typical factoring technique. So I'm going to zoom in now. Come over here to the right. Now the 2x comes along for the ride. I write an x and an x. I copy the first sign. Since that 9 is positive, I know a positive times a positive is going to be another positive. I write out the factors of 9. 1 and 9, 3 and 3. I know no matter what pair I pick, they're both going to be positive, and they have to combine to give me 6. And that only occurs with 3 and 3. So, plus 3 and plus 3. Therefore, the factored form is 2x times x plus 3 times x plus 3. And since you have 2x plus 3's, sometimes you may see the final answer as 2x times the quantity x plus 3 squared. All right? So that's it. That's how you use this chart. Eventually, we're going to be using every single one of these branches. Not in every single problem, but eventually we will, because we're going to study the only one we really haven't looked at yet are the binomials, okay? Because they're kind of special. In fact, the section that they fall in is called special factoring. So, but we'll get there when we get there, okay? So hopefully this flowchart helps. It's designed just to get you thinking in a systematic way, okay? See you in the next video. Bye.